So good morning. My name is Camilo Gomez. I work for Yokogawa as a global cybersecurity strategist at the US Technology Center. And as part of my work, I represent Yokogawa and work in industry standards like ISA and IEC, cybersecurity working groups and certification organizations. But more importantly, I'm also working on sharing the OPAS cybersecurity subcommittee. So let's start. The presentation of today, or my presentation is about OPAS, is an opportunity to advance industrial cybersecurity. So let's start with, let's start what OPAS is. So OPAS, as you can see here, is a standards-based, open, secure, and interoperable process control architecture. And I was slow there to say process control. This is a process control architecture with all those elements: standards-based, open, secure, and interoperable. From the list of elements in the vision that we have, I would like to highlight two, in fact, or three, one that is not there. This is an architecture that is applicable to multiple process industries because this is process control architecture. But I would like to highlight here that the elements in the vision from the stakeholders in this OPA forum is a key one is the design, the security by design, or design in adaptable security, as we call it. That's one element. And the second element that I would like to highlight is that it needs to be something that can be applicable in brownfields and greenfields. It's not just for the new, but it's to support the existing and the new. So what is this reference model? Well, it starts at the center. The core is this, what we call the connectivity framework. So the connectivity framework is a way to have secure, interoperable hardware and software communication. And this layer is responsible for ensuring deterministic and quality of services required for process control distributed systems. So that's a key element. So we have distributed logic systems. They need to interconnect. We are distributing the functionality that used to be in one box DCS now into multiple. The other elements important to highlight in this model, for sure, is we are talking about components as well that will work in this environment. But the components are not just physical components. We're moving away from the idea of device. So we call it DCN, Distributed Control Network node. This node is based or composed by two elements: the platform and we call the DCP platform, or the distributed control platform and distributed control framework for the software, where it's the place where the applications are going to be residing. What are the purposes of this? So we can have systems that are better applications, systems that interoperate with each other, and applications that can be ported among multiple vendor systems. Now, the node doesn't have to be a physical device, can be a container, can be a virtual machine, and that's what we call the element of the concept. The important thing is, as you can, another element you can see in this architecture is that we support both the new on the left, the ability to create devices, if you want, or components, as we like to call them, that interact directly with I/O, but also interact with the legacy systems. So, and they provide, by doing so, we are going to provide a common set of security throughout the legacy and the new. So those are key elements. One last word too. The core inner element of all these things, as you can see, is the application. The applications need to be portable. But for them to work, that DCF itself can be sitting also outside in the cloud. So that's part of what we have in our reference model. So what is the OPAS difference? As you know, well, traditionally, security has been bolted on an afterthought. Well, still, that's not necessarily going to change immediately. It's a process because we still have legacy to support. Most of that legacy will still require bolted on, not afterthought, but at least bolted on security controls, right, or countermeasures. What we're doing in OPAS, of course, is thinking that we need to design, have secure by design right from the get-go. So it's very important, and as such, we were very careful to incorporate security in all the internal and external interfaces of the architecture, as you can see here. So we have interfaces, security interfaces for the connection to the applications to the DCF, for the connection of systems within the DCP, and all the services that you require to support this. There's important realization here that you enable security features, but some of these security features require external services to work. An example, certificate management, right? And many others. ID management systems, they need to exist to enable the functionality, but if there's nothing on those side that will enable use the functionality, you have a gap. So we started by collecting the requirements from our end users and the OPA forum, and also from the other stakeholders. And as you know, we are a very diverse forum with OT, IT members, industrial automation, and IT vendors of all sorts. And we all came up with this list of what are the security requirements. So we have on the top a list of security requirements that start with the identification. And we just heard about trustworthiness. A key element for us in that part is, for example, root of trust, which can be related to the hardware, but also we need, because our end element is application, we are also concerned about the root of trust, how we trust the source of the application, the integrity of the application that we're going to use in the environment. So it's a two-way. And then you can have all the other elements that we have seen before everywhere else. Another key element on the right is configuration management. So asset and configuration management is normally overlooked, and some people think that it's separate. For us, it's key. It's part of the system. Because now we're distributing the functionality of one box in potentially thousands of devices. So to be able to control and know what is there, out there, and what they're running is a key element for security. And then we have elements. We need to give those same components need to provide some mechanism to ensure secure communications, secure data exchanges, allow them to work in restricted zones, and so on. And even allow information for auditing and non-repudiation tracking and stuff like that. And lastly, being able to provide meaningful information for security anomaly detection and other processes that are important, alerting for us. So it's not only enough to build the security functionality features within the components, but also we want to be sure that they are enabled through a process by the vendors of the OEMs, right? That is going to ensure that the functionality is going to be implemented in the products, but it's not only implementing the functionality. Part of the things we have seen is that it's not only necessary to implement the functionality, but also you need to support it, maintain it. You need to do defect management throughout the life cycle of that product. So that's the end goal. We want to have a supported product that with integrated security. Supported meaning that is end-to-end from development to production, implementation, production. And then, well, you heard the word, we're all standards-based, right? So that brings us to what are the many standards that we can apply for this. And if you are familiar with the two recently released standards from IC, or ISA 62443 4-1 and 4.2, they both fully align. So we're seeing a map. So now we're getting a picture of what good looks like for us. Now, are all the parts from the 62443 series applicable to OPAF? Not now. As you can see, they are all applicable through the life cycle of OPAF that we intend, but the scope of OPAF is about components, as I just displayed to you. So there are three standards we are concerned and are part of our framework. They are what we call our overarching specification, and they will help us define what are the security controls we want to have in our life cycle. And our cycle is about define, build, and maintain, as you can see. So what is OPAS version 1? The objective of version 1, and you probably will see it and hear more throughout this conference because we did the launching of the standard last week, and we're going to do additional presentations during ARC this week. But the version 1 is related to, we are concerned about interoperability first, not just configuration portability, not application portability yet, but just interoperability. We want to be sure that when you build a component from different vendors, they can talk. One thing we found out through this exercise is that security is the enabler to allow that interoperability. Because as you probably heard in previous presentations, if there are differences in terms of what are the security controls or levels that you want to apply, you won't achieve interoperability. So you need to define what are those common things. That's the step we went through. So in terms of OPAS functionality, the connectivity part, OPAS for version 2 interoperability has to do with the connectivity framework and system management features for hardware management. So we selected within OPAS 2 standards. OPC UA is our connectivity framework. It's not just a network protocol, as many people would think. OPC UA is a lot more than that. It's a framework. And it provides you different interfaces, layers, intrinsic security services, and so on. The good thing is, well, OPC UA and the security features enabled in OPC UA, of course, were not developed with 62443 in mind. So one thing we needed to do was to be able to map what is that functionality that OPC UA, security functionality OPC UA provides, and how it maps to the standards to see how good it is, right? Have a reference. And the same we did for the Redfish functionality we're doing. And we created 2 parts, in essence, or 2 sets. We have 3 parts that are explicitly talking about security in our standard specification for version 1. And the part 2 is defining the requirements. And part 4 and 5 are defining the functional requirements, the security features that you can enable in both OPC UA and Redfish. And that's it for me.